Swayam Prabha. Digital India. Educated India.
Welcome back. In the previous session we derived every man loves V2 by using B5, which is this rule, and the rule you cannot see, and already we have seen B6, the application of B6. We see also another derivation. So we have the same thing, xi V1 loves V1, and then alpha, our common noun, is man, and we now use V1 as our variable, and we apply V5 on V1 loves V1, and we are combining V1 loves V1 and man and V1. We get by V5 we get every, we get every man loves V1, and that is the first step, and then the subsequent occurrence, there is just one of V1, so that is now replaced by that man. So every man loves that man, so to say that every man is such that he loves himself. Yes, the language is problematic here, we are not having himself or herself, and this rule, that is rule 7, is about thee. If we have time we will talk about this, but not right now, because this is sort of complex, and we will take some time for talking about this. So we then go to the next rule. Phi is a formula by the above rules, and if phi is a formula by the above rules and contains no instance of any variable, then phi is a sentence. What does it mean? It means a sentence is something that has a truth value, but a formula does not have. For example, you consider, just contrast these two things. Every man snores and V1 snores, or Sadie snores. Now all three are derived by using the rules we have already used, but then 1, 2 and 3, but 2 contains a free variable. That is why, although it is a formula, it is not a sentence. All others are sentences, that is, every man snores may or may not be true, but it definitely has a truth value. Its having a truth value does not mean that we know the truth value. Once again, Sadie snores, I do not know whether Sadie snores, the model tells you whether Sadie snores or not, but anyways it must have a truth value, either Sadie snores or he does not, but V1 snores cannot have any truth value. So this rule converts a formula into a sentence. So that is it. Now the semantic values, this is the semantics part of it, and basic expressions, as we have seen. If u is a variable, so if u is a variable, then with respect to m it has got no truth value, because it has got no reference. I all the time confuse reference and truth values, so one needs to be careful when one listens to these talks, because but I try to correct myself also. So whatever, so then it will not have any reference, it will have a reference the moment it will be considered with respect to g, because g assigns references to each and every variable. So the reference of u is whatever g assigns it, any value g assigns it, and for phi we have seen it is f, for alpha it is f. Alpha is a non-logical constant like Sadie or snores or is taller than or loves or hates or anything, or and all that stuff. non-logical constant, sorry, not and, that is a logical constant. If alpha is a logical constant, member of neg or conj, then alpha mg is as follows, and we know that and will take 1, and then it will take 1, and then it will return 1, and it will take 1 and then 0, it will return 0, because we know that 1 1 is paired to 1 1 0 to 0 0 1 to 0, and then 0 0 will be mapped to 0. This is the value matrix for AND. We know this from the logic sessions, and for OR something similar is there. So the only difference is these two are different here, and if then we need to add, because we may like to have if then, why not. So if then will look like this, then 1 1 is 1, 1 0 is 0, everything else is 1, and then 0 everything will be 1, will be 1, and 0 also will be 1. This is for if then. It is not the case. That once again is very simple, and then we have the references of the common nouns here, man, woman, and fish, to say that if we want to talk about these, if you want to describe these, then we will have this. From this we know that Anwar Sadat is a man. So Anwar Sadat is actually we shouldn't say that Anwar Sadat is a man, because Anwar Sadat is the real person. We should say Sadi is a man, because Sadi is the name. Anwar Sadat is not part of my language, whereas Sadi is. And then Liz is not a man, and Hank is a man, and Sadi is not a woman, Liz is a woman, and Hank is not a woman. None of them is a fish. This is what the model tells about the common nouns, and about the other things. I think it will have its own truth value from somewhere. Will construct if required. Then the truth conditions for formulas of L1E relative to M and G. So corresponding to every syntactic rule, we should have a semantic rule. Now we shall see how that is possible. If alpha is a VT and beta and n, then alpha beta is this. So we can see what is going on. So what does this mean? It is something like, for example, loves Sadi. So alpha is a VT, and this is alpha, it is a VT, and beta is an n, this is beta, this is an n, so VT and n. Then what is the meaning of, or the reference of loves Sadi? It is with respect to mg, of course. It is the meaning of alpha, which is loves, combined with the meaning of beta, which is Sadi. So we remember how the transitive verb or the 2 plus predicate yields the value. First it takes the object, then the subject. So it is just the object, not the subject. And then together they make, we know that together they make a VI. So this is a VI. And then if alpha is a VI and beta and n, then beta alpha is this. So beta alpha is the meaning of beta alpha. So what we get several sentences. For example, let us consider Sadi snows. So now this was rule 1, this is rule 2. So we can see the same construction. So the point is, what is it? It will actually be, so this is actually beta alpha, this is beta, and this is alpha, but how the meaning comes, it will be the value of alpha, that is snows, combined with the value of beta, that is SADI. So, this will be the meaning. We can check it right now, but we need not, or alternatively it could have something like SADI loves Liz. So, this is a complex construction in a sense. It will be like this. First, loves will take Liz, as we know, and then the entire thing will take SADI. Of course, you have all the everywhere you have the index. I need not write the index everywhere, but anyways the index is there everywhere. So, yes, mg and also mg. So, this is how this is constructed, and if alpha is a neg and phi is a formula, then this. So, basically it will be the reference of phi, and the neg will take it as an argument and all that stuff, and conj rule. These are all very simple. We understand these rules pretty well. What we may not understand is this rule, maybe 5 and 6. We may first consider 5, then we go to 6. So, what is the rule? The rule is, if alpha is a Cn, u a variable, and phi is a formula containing at least one occurrence of u, then for phi prime, as in syntactic rule 5. So, we remember the syntactic rule 5 where we had something like every man or something like that. So, every man, every woman, and every fish. So, if we have a construction like that, then that thing will be 1, the value of that will be 1 if and only if for all value assignments g e u such that this, that is alpha, the meaning of alpha as a function takes the meaning takes e is 1, this will be 1. Now, it looks slightly complex, but I can assure that it is not as complex as it looks. We will see how it works. If alpha is a Cn, so what is a Cn? A common noun. We take, for example, man, and u is a variable. So, u a variable, we take v1. Then phi is a formula containing at least one occurrence of u, that is phi is the original formula. Suppose phi is v1 snows. v1 snows is a perfect formula. What is it? It is combined or it is constructed by using rule 2, this one, that is, here you have a vi and here you have an n. That is how it is constructed. So, and it makes perfect sense. If this is the case, then this is phi, and then what is phi prime? Phi prime is where, by following B5, the syntactic rule B5, that is, we are adding, say, as we said, man is our common noun, we are adding it to, we are applying it to the variable v1, and by using b5, which gives you all or every, not all, in our language it is every. So, what is then phi prime? Phi prime is nothing but every man snows. Now, what they are saying is the value of this, that is phi prime, every man snows with respect to mg is 1 if and only if for all value assignments g, e, u such that, that is a value assignment that assigns e the value e to the variable u. What is our u? Our u is v1. That means we need to consider a g or all value assignments g that assigns the value e to v1 such that the meaning of alpha with respect to mg takes e and gives 1. This will be the case that phi will give you this. What does it mean? We need to understand this. Now, I will try to make some space here so that we can do our calculation here. Now, it has got steps. The first step of doing it is sort of considering the g. So, all the g primes, right, that is here are g primes are the variants of g, and they are described in a slightly different way. In the previous language it was g prime, in this language it is g e u. Okay. Now, what is our g? Let us see the structure of g. This is g, and I will get back, this is our g, and g is fixed. G could be anything, but once you fix a g you must have the same g everywhere. I just want to write the value of g somewhere so that we can start calculating it. So, g is this v1 gets, I have written the abbreviated forms of all the individuals. So, as is Anwar Sadat, v2 will get HK, which is Henry Kissinger, and v3 will get QE, which is Queen Elizabeth II. So, yeah, I will use the short forms only. I am not going to use the big forms. Okay. Now, we are calculating the value of every man's nose with respect to m and g. It is 1 if and only if this. Now, g, our initial g is this. What are, there are 3 individuals. What are our g primes? Our g primes are, so the first g prime 1 will be g itself, that is here. Now, we need to consider only v1 because we have just one variable here, others will remain the same. So, we need not. So, v1 is as, and then v prime 2 is v1 gets the next one, that is hk. You could do anything else, like not that you have to do it this way. And then what is our g prime 3? These are all the variants of g, that is v1 goes to q e, others remain the same. It is not very clear. So, yes, it goes to q e, others remain the same. So, there would be just 3 variants of g, and so you see what is our u? U is v1. So, e actually is any value given to v1 here, and so these are the g primes in this case. So, these are actually in this language we call this. So, if you want to maintain this language, it will be something like this. This one is just erase this first and then do it. This one is the first one is as v1, the second one is hk v1, and the third one is qe v1. So, this is how you write. It is not once again very clear. So, the 3, just you can have 3 things, 3 variants of g, that is our g e u. We have to show that every man's nose is 1 with, of course, with respect to m and g, if and only if all these 3 value assignments assign the truth value 1 to phi. What is our phi? Our phi is V1 snows. We shall see whether this is true or not. So, what is the meaning of V1 snows? So, the meaning of V1 snows is, we start calculating here. V1 snows, I'm just omitting the index. You add, it will be actually snows and then V1, we know this. So, now this is our formula, that is snows V1. Now, we need to vary, the variable, and we can see that snows V1, what is the truth value of it with respect to m. You see, you must have the same this thing, the same base as V1. Once again, m g as V1. What is it? So, this will actually be, what is the value of it? I am not writing each and every step. So, it is basically V1 gets as, and we need to now see whether this snows as gives us 1. So, the value of snows, you can refer to the values. I can see it in my notes that the value of snows. Okay, let us construct the value of snows. It is not a big deal. So, suppose snows is something like this. Snows, suppose as snows, that is Sadie snows, and Liz snows, whereas H K does not. Suppose this is the structure of snows. Now, if this is the case, then we will stick to this. So, for us snows will be this. Now, as is mapped to 1. So, yes, I get 1 here, and then you see it is all value assignments G E V1. So, we have checked 1. Then the second step is the same thing, snows, and then V, once again M is the second one. So, G, what is it? Our second one is H K with respect to V1, and the same here, we do it like that, M G H K and V1, and this will then definitely be H K, and once again this is 1, this is 1, and the third one same thing, once again the same thing. I am not doing the index V1 with respect to, now the index changes, it is now M, and here it is there, I am not doing it. After H K it is Q E, and sorry, this is H K gives 0. So, actually this was 0. So, actually we have got our answer. So, it will be 0. We may check this, it will be 1, but the point is, the moment we arrive at this, we know that this cannot be true, because it must be a case of and, because all G E V1 must give 1 to the truth value 1 to this formulation snows V1. That is not happening. Since that is not happening, the truth value of this will be 0. So, we compute the truth value of it. Once again we revisit, it will be 0, simply because one thing fails to do, one thing fails to give 1. G H K V, this value assignment fails to give 1 to the formula V1 snows. Since this fails, if 1 fails, then we fail as a case. So, then this case gets the truth value 0. We can see that very easily. And then what about something like, we just change it to some man snows, and once the same thing changes here, it will be some man snows. Snows remains the same. Here the rule is not anymore B5, but it will be B6. Everything else the same by following, that is this rule, which is not shown here. If we want to do it afresh, we can, but we can use these values, so we need not go anywhere. So all other things remain the same, but this part we may do separately, or just see. Now what is the requirement? The requirement is at least one value assignment. You can see it here. If alpha is a Cn and u a variable and phi is a formula containing at least one occurrence of u, then for phi prime, now it is about some man snows. Phi prime, as in syntactic rule 6, phi prime mg equals 1 if and only if for some value assignments g e u such that the entire thing, this is 1. Remember that B6, the syntactic rule B6 is about sum. We get back to the old page, and we see that here we at least some value assignment, at least one GEV1 should give 1 to this formulation SNOS V1. We find, yes, even the first one, that is G itself. G itself is also a GEV1, it is GASV1. This with respect to this value assignment, that is GASV1, SNOS V1 or V1 SNOS is 1. Because 1 is satisfied, we must say that this with respect to m and g is 1, but our job is not done. The moment we now apply this for any sentence phi of L1e, the meaning of phi with respect to m is 1. If for all value assignments g, the meaning of phi with respect to mg is 1, which means that yes, you do not have to calculate it several times, but you have to have this step. Since this is 1, therefore, because we have already shown how just by checking one g you check all g's equals 1. Now you are done with it. So this is how the calculation goes here. So this is all very simple, but it becomes complicated when we have many different variables. So we will consider such cases where we have many different variables in the next session, but we start with 2 plus predicates now, and so for example, suppose we add one person to our system. We will do some, so this is the function, and we know that we just copy pasted this function from here, and suppose we know that we just add one person to our model, and we'll redefine a 2 plus predicates, and then we'll see how it behaves. So what is our one person? Let us call that person Kamla. So Kamla is the name, and the reference of that is Kamala Roy, in short KR. We are using the short forms everywhere. So after doing this, we will also redefine loves. The textbook gives some example of loves, but then we are going to use this thing for loves. It means that Sadie loves himself, Sadie loves Les, then Hank loves Kamla, and Hank loves himself, and Liz loves herself, and Kamla loves herself. This is what loves is, but then the denotation, the reference of loves is, and nothing else loves anybody else. So this is how the structure goes. We need to determine the truth value of Liz loves Hank. You see, it's a very simple one. Why is it a simple one? It is because it doesn't have any variable. So it is now what is the derivation of it? So the first part, loves and Hank unite and makes it loves Hank. What is the rule? The rule we are using here is R1, which is if alpha is a Vt and beta and n, then alpha beta is a Vi. So this is the syntactic rule to make it. What is the semantic rule? The semantic rule is actually this: loves Hank. I'm not doing the index all the time, but we must add the index anyway. Loves Hank. What is the value of this? So basically, loves is this big function. This is just the functional form of the set theoretic form we have just now seen for loves. It's the same thing, which says that Anwar's, that is Sadie loves himself, and then Sadie loves Liz, and Liz loves herself, and this says that Hank loves himself, and Hank loves nobody else, probably. Okay, fine. And is it the value of loves? Here we find that Hank loves Kamla, so we just correct it a little bit. So actually this will be 1, this will not be 0. Let us correct it. This will be 1. So everywhere we are going to correct it. This is also 1. Okay, so this small correction we had to make here. So you have this. Then loves Hank, our sentence, original sentence is once again Liz loves Hank. So this is this function, Hank's is this function. So the together gives this function, right? So loves Hank is actually just loves Hank is this function. And then what is the value of Liz loves Hank? There the rule is this, if that is rule number 2, if alpha is a Vt, loves Hank, alpha is a Vt, and once again there is a problem here. So actually this will be Vi. So we corrected it in the, so once I typed it wrongly, always it comes wrongly. So then this is a Vi actually, not a Vt. If alpha is a Vi and beta and n, then beta alpha is a formula. Now what is the semantics of it? Our sentence is Liz loves Hank. I am not giving the index of it, which means that loves first takes Hank, that function takes Liz, and we have seen this much, which means that this is actually this one where it is 0 0 1 1. So we just copy it there, yeah, this one, right? And so there is nothing wrong in doing it. QE is 0, and as we corrected it, this is 1. This is 1. So then HK is 1 and KR is 1. Then so it is only this much. that thing takes the reference of Liz, which is QE. So, you see this, and as a result of that we get 0. So, we compute the truth value of Liz loves Hank, and it is 0. Now, we just go. So, this is slightly more complex than the previous one. It is Liz loves some woman. Let us see how this calculation goes. So, we have the derivation here. The first rule is loves plus V1. So, where we use rule number loves plus V1, rule number 1, and then we add Liz to it. So, it is rule number 2. So, here this is the construction of our Vi, and this is the construction of the S, right. So, finally, because this is an S, not an S, it is a formula. It is a formula because it has got one free variable. So, it is a formula. Okay. So, then the steps of construction: Liz loves V1 plus woman, that makes it Liz loves some woman. Now, we need to check the entire thing, and we need to see what happens with this. So, you are doing it by using rule B6. What does it mean? The old sentence was, this is a syntactic rule, Liz loves V1. We have already constructed it by using 2 rules, and then this is our phi. If we remember, this is our phi, and then we add the common noun alpha, right. As you see, use a variable, phi is a formula containing at least one occurrence of u. Then phi prime is the formula where phi prime comes from phi by replacing the leftmost occurrence of u by some alpha. Alpha is a common noun. Our common noun is woman. Our sentence was Liz loves some woman here, and then we are using it with V1, and our rule is B6. By applying this, what we get, phi prime we get, and phi prime is Liz loves some woman. Now we shall try to determine the truth value of Liz loves some woman. How to do it? So, this is phi prime. Here we get the formulation. Liz loves some woman is derived from Liz loves V1. Now, Liz loves some woman with respect to mg is 1 if and only if for some value assignments g, e, u such that, now this is the point here, such that woman mge is 1, Liz loves V1 with respect to m and GUE is 1, right. This is what now we have to do. That is, now there are 2 conditions. This is very important. This is one thing we have to consider. What? So, phi has Liz loves V1. What is the value of it? The value of this with respect to m and g will be, what is the structure of g? Once again we just write for our convenience, all the time we need this for our reference. G is actually V1, V2, V3, and this is AS, this is HK, and this is QE. This is QE, and then so that means V1 gets AS. We need to check whether Liz loves AS means Sadie, whether Liz loves Sadie or not. We can check that very easily. So, basically it means that as G gives this will be 1 or 0. We check the value whether, so first it takes loves is this big function, then it takes Liz the object, not this, not this. So, let us for the timing block it as if pretend that it is not there, it is not there. So, we are adding something instead, we are just adding this, we are adding what is Liz is QE. So, we are adding QE to it, and what we get is not this. So, pretend this is not there, we get actually this thing. So, this will come out. So, this will come out, that is this function where it is 1 1 0 0, and then we will carry this function to the next page, and we see what happens 1 1 0 0 as we said. So, it will actually be AS QE HK and KR. I can see that from my notes all the time, and I can always correct it. Yes. So, this is 1 1 1 0 0 1 0 and KR is 0. So, it is just loves V1, because V1 automatically gets its value from G, and G assigns what is AS to it. AS means actually SADI, and then it gets Liz, which is, so the meaning of Liz is QE. Actually, it takes SADI, which is AS, and gives this one instead of that. So, it is 1 0 0 0. So, it is 1 0 0 0. Then it takes QE and gives 0. So, yeah, it was a small mistake there, because I find it very looking at it, I find looking at this very complicated. So, it shouldn't take QE, it should take AS instead, because the question is Liz loves SADI. So, the object is SADI, so that should come first. SADI means AS, which is Anwar Sadat. Anyways, so that is how we see the result, and we get so the result of this will be 0. So, this is the first step. What is the second step? The second step is calculating the value for Liz loves some woman, which is slightly different. So, now we check the value of Liz loves some woman with respect to M and G. As I said, just by doing this part, we are one step ahead, and then we have to calculate the rest. How to understand that? So, we have already checked some value, Liz loves whatever. Now, what will be this one? Liz loves some woman. It will be it derives from Liz loves V1, and now sum comes here. So, here there is a sum. So, there are actually two commands for us, two things to be understood. One, here there is kind of a sum V1 sitting here, and two, woman, which is the set that is given somewhere. So, who is the woman? So, basically this is there are two women. So, AS is 0, and then QE is 1, and HK is 0, and KR is 1. Okay, now we shall see this. Now, according to this rule 5, Liz loves some woman is 1 if and only if for some value assignments GEU such that, so there are two conditions. One, this must be satisfied, and 2 this must be satisfied. That is E, whichever value, at least one value E has to be a woman. Now let us see, so whether both the value assignments, both the conditions are satisfied or not. So Liz loves V1 with respect to different value assignments. We will have 3 value assignments, so we will have just 3 things here, right. So and also we have 4 things, so maybe we have yeah, so that is it. Now Liz loves V1. You see that the first thing, so what are our G's? So the convenient G's will be G, so or we can write in the format they have given, which is actually EU. So the first one is AS V1, that is basically it will be V1 will get AS, the rest same. The second one will be we just change, will be QE, which looks like V1 QE, the rest same, and then 2 more, and we understand this HK V1, which gives HK, and lastly G KR V1. These are all the G's, all the value assignments we need to consider. So the point is here, it should be satisfied for some value assignment. So let us check. Liz loves V1 with respect to different value assignments. What will happen? So we just need to make some space here, so that we can write, and then we will check the value. The first one is Liz loves V1 with respect to MG, and G in this case is the first G, which is this one ASV, we just write that. So ASV1. Now does Liz love Sadie? No, Liz does not love Sadie, that you can check. Liz loves herself and nobody else. This is the value of loves. So only 2 people love others, that is Sadie loves Liz, and this we need to sort of remember, otherwise it is very difficult, and Hank loves Kamla, nobody else loves anybody else, and everybody loves himself or herself, that is one thing. So we need to remember this, then it becomes easy for us to calculate. Okay. So Liz does not love Sadie, this is 0, no problems, because at least some should satisfy. So one value, so 1 has not satisfied, but out of 4 1 should, and then at least 1. Liz loves V1 with respect to M. This is the second G prime, or whatever GEU, that is G Q E V, which is when V1 gets QE, which is actually Liz. So Liz loves herself actually. The case is, the point is, yes, the fact is she loves herself. So this is 1, and she does not love anybody else. So we can easily write, we know that from the structure of loves, we know. So we can write MG. The third one, HK V1 is 0, and the fourth one loves V1 with respect to MG. KR V1 is also 0. It does not matter, but so the first condition is fulfilled. At least one GE V1, that is this one, at least at least this one, that is G QE V1, assigns 1 to our phi. Phi is Liz loves V1. So the first condition is fulfilled. The second condition is this E you take. What is the value of E here? QE. If this is also fulfilled, that is, if this is also true, that is, woman MG QE is 1, then and only then. So, this is condition 1 and this is condition 2. If this is 1, then only can we say, then only we can say that Liz loves some woman is true. Now, is this 1? We can easily see that this is 1, because Queen Elizabeth is a woman. We know that, because 1 and 2 are satisfied. So, this is 2 and this is 1, because both 1 and 2 are satisfied. We can say, therefore, Liz loves some woman is true, because Liz loves herself and she is a woman. So, as we see that, we have to fulfill 2 conditions here. What about if we just change this to Liz loves some man, what happens? Other checkings, all checking cases will be the same, right? So, everything else will be the same. So just we change this and then we see what happens. In this case, this will also be the same, because this does not concern anybody's being man or woman or anything else, but this part will now change. So, as we can see that this is not woman anymore, this is man. And what is man? The structure of man is different. That is, now it is this is 1 0 1 0, and now we change it to man, and once again, although one value assignment GEV1 satisfies this one, only one satisfies this. So, we can just take this one and nothing else, but the point is whether this is true or not. Is this true? Man QE. So, then we how to determine this? We put this value here, where you have just this AS1 QE 0. So, others are not required, and QE, which means that you get 0. Since this is 0, since it satisfies one condition without satisfying the other, the whole thing, that is Liz loves some man, will come to be 0, whereas Liz loves some woman will be 1. And this is how we compute truth values of some formulation. But then that is not everything. There are also, one step still remains, that is, this is with respect to M and G. So, the next step will be, if we still stick to the old thing, that is Liz loves some man. So, then it will be Liz loves some man with respect to M is 1, since it is 0, since Liz loves some man with respect to M and G is 0. This is this we do by following the rules like this. I think we need to get back to the rules every time and check whether yes. Now, this is the rule for any sentence phi of L1E. the meaning of phi with respect to m is 0. If for all value assignments g, this is 0. Now, all value assignments g, it will be 0, because every path we have seen also will consider all other paths. So, if one path yields the result 0, all paths will finally have to yield the result 0. So, that following this rule, we say that this will be 0. That is it. Now, in the next session, we will deal with ambiguities. So, the structural ambiguity, also we will talk about ambiguity, and we will deal with ambiguities, and we shall see that a sentence as innocent as every man loves some woman is not so innocent. It may have different interpretations and different explanations. So, that is it. Thank you very much.